All right, ladies and gentlemen, off to our next presentation. That is by Merichem Technologies, presenting clean fuels, monetized gas technology pathways to upgrading Africa's energy. Presented by Mr. Malcolm G. Sharpe, the Senior Technology Licensing Director. Sir, over to you.
Thank you much. Appreciate it. Good afternoon, everyone. Thank you to the organizers for the opportunity to speak today. Welcome to our presentation, Clean Fuels, Monetized Gas, Technology Pathways to Upgrading Africa's Energy. I'll begin with a brief overview of our business, our products, and the applications across upstream, midstream, and downstream sectors. Afterwards, my colleague and friend, Lance Green, will speak on H2S removal using our low-cat license technology, as well as our sulfur trap adsorbent systems. So let's begin. At Merichem, we pride ourselves on being a single-source technology provider. That means turnkey solutions from licensing to engineering, proprietary equipment, and chemical supply. Our customers handle civil and foundation work, while we deliver the modular units ready for plug-and-play installation. Our scope includes the license to operate the unit, basic engineering, proprietary equipment, including optional unit modularization, manufacture of our own chemicals, and research and technical services for ongoing support. One of several things that makes Merichem unique is that we are not just licensors, we are also fabricators. To my knowledge, no other licensors in this space also fabricate their own equipment. That combination allows us to control quality, schedule, and cost. We focus on caustic and amine treating and redox processes for sulfur and acidic impurity removal. We do everything in-house, the technology license, equipment, chemicals, and services. We can accelerate delivery and ensure reliable startup and performance. To date, we have over 850 licenses spread across the world. These technologies include Thiolex, Regen, Merichem, Aquafining, Napfining, Mericat 2, and Merichem. Most of these are extraction or sweetening processes built around our fiber film contactor. Our entire portfolio consists of about double the technology that you see listed here, but these 8 are most suitable to the African continent. Thiolex and Regen, as you can see, are the most dominant. They represent half of the licenses that we've issued to date, and they are complementary. Thiolex is going to extract mercaptans into caustic, which will then go over to the caustic regeneration technology, Regen, to regenerate it for continuous use. We flexibly apply these technologies across 13 major feed types that you see listed here. The LPG stream is the largest share, followed by kerosene, jet fuel, gasoline, and so on. The pie charts here also show how these licenses are distributed among both technologies and the feedstocks. A key point, extraction is going to dominate in the lighter fractions of hydrocarbon, while sweetening dominates in the heavier fractions, such as jet fuel and condensate. We use aquafining on jet fuel, and Merichem is used to neutralize effluent acoustics for safe disposal. By geography, on the continents, you see Asia is leading with 38% of the licenses around the world, followed by North America at 30%, then Europe, Middle East around 10%, and we got South America, Africa, and Oceania rounding out the balance. On a country level, you'll see the US leads the way with 192 licenses, followed by China with 67, then Japan, Qatar, and so on. And the top 12 that you see here are licensees that we've issued 20 or more licenses to. But you can see worldwide we've granted licenses in 52 countries to date. This global reach shows the breadth of adoption and sets the stage for Africa, where we believe the same trajectory of growth is possible, much like what the shale gas revolution did in the US, and now similarly 10 to 15 years later in Canada. Okay, now let's shift gears and Look at how the magic happens. All right, depending on the fraction, the hydrocarbon fraction, the treatment objectives will vary. For LPG, the key specs that we're trying to meet include copper strip, total sulfur, and mercaptans. For distillates, naphthenic acid comes into play along with mercaptans. For gasoline, we're going to touch on the copper strip, total sulfur, and the doctor test. And finally, for jet fuel, kerosene, we're going to be looking at copper strip, acidity, mercaptans, and color. As the fractions get heavier, once again, extraction alone is not enough. We must combine extraction and sweetening, and eventually rely mainly on sweetening to sweeten up the heavier mercaptans, up to and including an impregnated carbon bed. Here we see a simplified refinery schematic with the typical refinery products on the left-hand side coming into the Merichem technology block there. And each fraction from LPG to diesel to crude oil can be treated with our technologies. Thiolex handles extraction in the lighter fractions again. Regen is going to regenerate the caustic that has extracted the mercaptans. Aquafining is used to remove and train caustic, primarily from jet fuel. Mericat and Mericat 2 are used to sweeten heavier mercaptans. And then Merichem is a technology that we use to either neutralize, acidify, or oxidize effluent caustics. Now hear this, Merichem is the only licensor capable of treating crude oil. So if you have a crude oil stream, we can treat it directly with the fiber film contactor as well. Okay, so let's start to get into a little more of the nitty gritty. This is not Merichem technology here. This is what not to do. Dispersive mixing and settling is what not to do. So if you remember only one thing from this presentation, remember, never disperse to treat. And that's what you see here in the top half of this slide. Conventional mixing disperses caustic into the hydrocarbon freely. So you got a bunch of these caustic droplets floating around in the hydrocarbon phase. And you're going to need to separate these again after you've completed the treating. The reason why you create droplets is to get interfacial area. The magic happens at the surface of these droplets. And then the problem is once you create these droplets, again, you have to separate it. So if you look at the bottom half, you see the dispersive mixing devices. And then in the middle, you have the separation. All of this extra equipment we don't need with the fiber film contactor because we don't disperse caustic or amine as droplets. So we don't have to separate them again. So how do we do this? With the fiber film contactor. So we take that same droplet that you see here, those blue droplets, and instead of freely releasing it into the hydrocarbon, we suspend it on a fiber. And you'll see the fiber film contactor, it's like a ponytail. The caustic wets the fiber, the hydrocarbon flows in between the wetted fibers, so we press the two layers up against one another, and that's how we extract the impurity and get the interfacial area that we need. And you can also see on this slide, that droplet, that same droplet now, has exponentially more interfacial surface area. The red arrows are the hydrocarbon, again the blue is going to be amine or caustic, so we stretch that droplet down and along the fiber. Okay, the caustic stays on the fiber, and it only separates when we get to the caustic inventory at the bottom of the vessel. Okay, so we never freely release the caustic into the vessel. As a result, we achieve a very efficient mass transfer, 80 to 90% plus of a theoretical stage efficiency. Residence times with what not to do with a conventional dispersive system, these vessels are typically 60 to 90 minutes versus the Merichem vessels with the fiber film, 10 to 15 minutes with our classic fiber film contactor. The next gen fiber film contactors that we have now actually reduce residence time to 5 to 10 minutes. Again, without dispersive mixing. All right, so this process flow diagram here highlights the heart of our technologies. Again, the Thiolex regen is our bread and butter. That's 50% of the licenses that we've issued worldwide. And again, it's going to involve the Tholex section here on the left-hand side is where we extract the impurities from the red hydrocarbon into the blue caustic. Then you can see we add heat, catalyst, and air in this oxidation tower, and that's where we generate the mercaptans, okay, to what's called disulfide oil, okay, and that's a sulfur oil. And then the DSO gravity separator is a bulk separation of this disulfide oil from the oxidized caustic, because we're going to take a next step. We can solvent wash as well if you need to really polish the caustic for the DSO, because if you don't take it out and you return, it will get back absorbed into your product, okay? So depending on how much sulfur you have to remove from the hydrocarbon and what your product specification is, determine, to what degree we have to remove the DSO from the caustic. But, full cycle, you see a continuous operation with minimal entrainment and also full caustic recovery. Okay, at this point, let me see. Actually, I'll show you some pictures as well. So this is what it looks like in the real world. The two on the left, those are the Tholex vessels. The oxidizer tower is here in the middle, and then you have the DSO separator to the left of the oxidizer tower. To the right of that would be a solvent wash. This particular unit is actually treating propane and butane. It actually has a COS removal step, which we can add, that's optional. Okay, but that's what it looks like in real life. So now I'll turn it over to my colleague Lance. He's going to pick up to discuss low-cat and sulfur trap.
All right, thank you, Malcolm. So today I'm going to discuss H2S removal from sour gas streams utilizing our sulfur trap, fixed bed absorbent technology, and also low-cat technology. So first up, I'm going to talk about sulfur trap. Sulfur trap generally fits well for streams that consist of less than 1.5 tons per day of sulfur. Sulfur trapping is applicable towards a wide variety of different sectors, including upstream, onshore, and offshore production, midstream, natural gas processing, transportation, and storage. Downstream, petrochemical refining, syngas, carbon capture, and then also renewables, anaerobic digesters, agriculture, landfill, and utilities and wastewater treatment plants. So the basics of sulfur trap. So the sour gas flows in through the top of our sulfur trap vessel, which flows over a bed of media and exits the bottom of the vessel containing less than 1 ppm of H2S. As the sour gas flows over the media, the H2S reacts with the iron oxide, producing iron sulfide. As I mentioned, generally, our sweet gas contains less than 1 ppm of H2S. So one thing that's really good about sulfur trap is it's very flexible in terms of conditions. So gas flow, H2S concentration, temperature, and pressure are also very flexible there. In addition to that, one of the advantages or some of the advantages of sulfur trap is that it has a low pressure drop and also considered as non-hazardous as well. Our typical sulfur trap unit consists of a double vessel lead lag design. So this particular design allows for you to change out the absorbent without interrupting any of the upstream and downstream processes. So as you can see, when the adsorbent is spent or fully utilized, we switch over to the lag vessel. That will become the primary vessel of usage. As I mentioned, no interruptions in terms of the upstream and downstream process. In addition to that, the lead lag design also ensures that we consistently meet product spec in the sweet gas as well too. Off to the right side, you can see that we have, that's a 3D imagery of our sulfur trap unit. It consists of an upstream knockout pot, our double vessel lead lag design, and then also downstream filter as well too. This is just a little illustration of a change out of the absorbent and how we would divert the sour gas throughout the vessel. Okay, now I'm going to talk about our liquid oxidation catalyst technology, or better known as LOCAT. So LOCAT generally fits well for sour gas streams that consist of 1.5 to 20 tons per day of sulfur. So it fits really well between the adsorbents technology and also the Klaus units. And this is based on OPEX and CAPEX. Here, Merichem has over 250 licenses worldwide. Our treated or our primary treated gas streams are acid gas. In addition to that, associated gas and biogas, and then fuel gas as well too. Okay, so LOCAT is an aqueous-based ambient temperature process, converts H2S to elemental sulfur, utilizing chelated iron catalysts, and has removal efficiency of 99.9% of H2S from the sour gas stream. It also has a very high turn-down rate, and we can process any gas stream containing H2S, so fuel gas, acid gas, sour water stripper gas, biogas, and syngas, and many more. So our LOCAT technology consists of an absorber, an oxidizer vessel, and then also our proprietary sulfur filter. So the sour gas enters in through the bottom of the absorber and flows out as sweet gas from the top. As the sour gas flows through the absorber, H2S is absorbed. H2S is absorbed by our LOCAT solution, which then converts the H2S to elemental sulfur. That elemental sulfur and LOCAT solution then flows over to our oxidizer vessel, where the LOCAT solution is then regenerated and sent back over to our absorber to be reused in the process. There's a slipstream that also flows over to the proprietary sulfur filter. And from there, that produces our sulfur cake, which can be used in various areas such as fertilizer or sulfuric acid production as well too. Okay, LOCAT application experience. So here at Merichem, we've got experience ranging from natural gas, acid gas, FPSO, offshore gas production, fuel gas, refining, sour water, fuel gas, overhead gas, petrochemical, gasification, landfill and other biogas, and geothermal non-condensable gases as well too. As I mentioned, we have over 250 licensed units worldwide.
Okay, I'll take a couple minutes here to wrap up before we take any questions, if there are any. So we didn't have a lot of time today to cover the many technologies that we have. So what I've done is included an appendix of some slides that I think that may be useful in the future to just learn a little bit more about what we do as far as treating these hydrocarbons around the world. So again, the first, this is the table of contents for the appendix, but the first appendix is going to be, again, a list of the technologies that we provide. All of these are licensed technologies involving a license fee, a paid-up license fee, fiber film, which we've covered extensively. We got the Merichem technologies. This treats effluent caustics and makes it safe to dispose of. LOCAT is what Lance just gave us a presentation on. And then we round out our offering with our catalysts and absorbents. Again, sulfur trap, which Lance presented on, and then we have the catalysts that go along with our fiber film and low-cat processes. And then finally, we offer carbon beds as well, primarily for jet fuel treating. Here's a simplified refinery diagram, this time showing some of the refinery ops. In the blue, you're going to see where the Merichem units are inserted for treatment, and in light blue above the boxes, you see the impurities that we're able to remove with these various technologies and technology combinations. This one gives an overview of a typical midstream product sector. You know, methane all the way down to natural gasoline and condensate. When starting with propane on down is where you know, the fiber film technologies would apply, and then the methane would be where low-cat applies. So we see that here on the next slide. This is, again, another shot of the midstream. And in this case, we're actually showing you some of the fractionation equipment. And again, the blue boxes are the Merichem technologies and where they would apply in this midstream process. This slide shows extractability using amine, caustic, and water. It shows what impurities that can be removed using these reagents, and also which ones deem these reagents regenerable or non-regenerable after they've extracted. Let's see, this slide here is just going to show you the Tholex reactions. This is actually where with caustic, RSH is the mercaptan, we're going to create that sodium mercaptide. Now we're going to bring that sodium mercaptide in the caustic over to the oxidation section that we mentioned before. That's where we're going to add the air, oxygen via air, catalyst, there's some heat added, and what you see is you 100% regenerate NaOH. Okay, so you fully regenerate your caustic, and the overall reaction is the combination of the extraction and oxidation. And then you see here on the bottom line, you consume mercaptans, well, you convert mercaptans all to DSO, and you make a little water, but you fully regenerate the caustic, so there's no caustic consumption. You just dilute the caustic batch over time. And this overall reaction is also reflective of our Merichem technologies, because in the Merichem technology, we do everything in one vessel. We oxidize, create the disulfide oil, and in that same vessel, it goes right into the hydrocarbon. So that is not an extractive process, it's a sweetening process, because we just go from mercaptan to disulfide oil, which is much less volatile, and you don't have the odor. Okay, this is be the last slide of the appendix, more about caustic. You see at the top what we can use caustic to remove as far as these various impurities, but at the same time, we have given you some limitations of caustic. Such things, non-acidic impurities, sulfur impurities, such as organic sulfides and disulfides, thiophene. We can't touch those with caustic. Unfortunately, that's a much more expensive proposition known as hydrotreating. So I believe that's the last slide. In closing, we'd just like to say that we know that Africa has vast hydrocarbon resources that can and should be upgraded locally. The transition that we see are going to require propane, butane, gasoline, jet fuel, and diesel produced here in Africa, not imported. Our technologies have been proven worldwide, and we are eager to partner in bringing that capability here on the widest scale possible. And again, we thank you for your time and look forward to any questions and exploring any opportunities to collaborate. And we'll leave you with a new hashtag, Refine Baby Refine. Refine Baby Refine. That's the next step. Thank you for your attention.